my dear friends, and namaskar to all my delegates. So, welcome to this webinar series, which is organized by Tata Tiscon. Here we are again starting because due to this some technical difficulties, we received some messages. So, we are here again starting the webinar. And the topic of my webinar is the smart structures for the future. So for this webinar, I will give the presentation for 40 to 45 minutes and the remaining time will keep for the question answer sessions. So I would like to request you all, please send us the questions and the queries regarding this webinar. So our technical team will compile it, and after my presentation, I will give my best to answer your questions. Now, see the smart structures for the future. I will highlight or I will discuss with the help of these points. That is, what is the necessity of the smart structures? What is the concept behind it for the development of the smart structures? What is current need and the relative research program set by different researchers? What is a component? What are the different components of the smart structural system? Classification of the smart structural system based on its working conditions. After that, I will move towards to highlight or discuss the working of the smart materials which get used in a infrastructural projects. And finally, I will give the application or I will discuss the application of the smart materials which are getting used in structures with the help of funded projects on which I am working from last 2 to 3 years. Now see, what is the necessity of the smart structures? See, it is required to develop a smart city. It is required to develop a smart country. Based on the case studies reported in the magazines, maybe in a research papers, as well as in the news, what it predicts, the structure having the life 15 years and beyond, it suffered from a durability distress. And how we can see that durability distress in the form of cracking to the spalling of the concrete. Same time, corrosion is also there. We can observe the severe vibrations in the structures, maybe the failure of the component of the structures. See, what is the basic reason behind that? Basically, if the water enters in the concrete, it reaches to the reinforcement, and from that point, the corrosion started, and it leads to a corroded and a weak structure. So, based on this scenario, it is necessary to keep building, maintaining safely, as well as to it is required to help the engineers to recognize a poor structural conditions and the related safety issues. For this purpose, the development of the smart structure is very, very important. Now let's see the concept of the smart structure. See, this smart structure system or this community is fairly new. That's why the many engineering professionals are attracting towards it because of its innovative technologies. This smart structure incorporates the sensing, phenomenon, actuation, along with the electronic transfer processes as well as we can say the controlled unit. See, this new generation of the system which shows the innovative functions such as sensing, actuating, along with a shape morphing, vibration control, buckling control, along with a advanced structural health monitoring. In addition to that, these smart structures which develops the special stiffnesses and strain to the structure and which cannot be seen in the conventional material or in the conventional structures. This is the plus point of the using a smart structure. If we want to define a smart structure generally, the structure which is able to sense the external stimuli and it may act appropriate or according to that changes to control the structural responses. Now let's see. What is the current need and what is the current program set out to develop a smart structures? See, this idea of the smart structure is adopted from the nature, and it is due to or it is based on the stimuli and responses capability of the living organisms. Same time, the researchers are taking effort to develop this system which is based on the example of a mimic living organisms. For example, take the example of a human body. The responses and the stimuli of the body is controlled by the brain with the help of a neuron systems present in the body. So based on this research, based on this theme, the researchers are developing the smart structures. See, what is the ultimate aim, or what is the focus behind that? That ultimately there is need of a structural member that possesses the enhancement in the deformation capacity and the ductility, higher damage tolerance, decreased residual crack size, and recovered or reduced permanent deformations. So these functions we can expect in the smart structural systems. Now let's see here this figure. In this, we can see a burger, pizza, and Coke. I'm also loving to eat this, but up to a limit. If we'll follow a unhealthy life, it resulted in what? Unpredicted damage, for example, heart attack, or maybe the failure of the organs. Similarly, if we'll compare this life example with a structures, suppose if we'll use a poor building materials, or even we can say a conventional materials, there is no monitoring, no preventive measures, there is no timely repair and the restoration or the rehabilitation of the structures. What happened? It resulted in the short and the unsafe life of the structure. So now, inversely, suppose if we'll follow a healthy lifestyle, see, this is a good anatomy. We can see in this figure, there is a regular checkups, preventive measures, and a timely cure. Okay, if we'll follow this, it resulted in what? The long and healthy life. Okay, take similarly, if we'll compare this human anatomy with the smart structure, see, if we'll use a smart materials, there is a regular and a real-time monitoring of the structure may happen. Then preventive measures will apply and the timely repair and the restoration of the structures. That is possible due to the only use of a smart materials in the structures. And it resulted in what? Long and safe life of the structure. Now let's see, move towards the components of the smart structural system. See, this figure shows that the smart structural system here, suppose we'll take or we'll place a structural system here and it is attached to the sensors, actuators, and along with the responses from the sensors and feedback to the actuator can be controlled with the help of a controlled unit. So this structural system can sense the external stimuli in terms of the stresses, strains, maybe vibration, etc. Corrosion potential is also there, electric magnetic field that is based on the different properties. So this external stimuli can be sensed by the sensor, and this sensed stimuli transferred to the electronic transfer system, or we can say it transferred to the control unit. Here, after analysis, the control function can be provided to the actuator, and actuator will behave according to the control functions, and particular stimuli can be controlled. So this is the loop system, and this overall system is called as a smart structural system. Here we can control the responses in terms of the motion change, vibration, deflection, surface tension, etc. Now let's see the classification of the smart structural system. See, I discussed the smart structural system. Based on its working phenomenon, this structure is divided in different parts or the points. See, smart passive system. This system is having ability to respond to a stimuli and behave with an appropriate manner without any assistance of a controlled unit or the feedback system. In active system, smart active system, see, this system utilizes the feedback loop, and after analysis the control can be happen, and so this system is called as a smart active system. Now what is the smart intelligence system? See, it is exactly similar to the smart active system, but the system is itself is able to control the external stimuli and the responses as per the demand of that particular structure. So it uses the nonlinear properties of the sensors as well as actuators. So, and this is the very advanced intelligence system. So it is called, that's why it is called as a smart intelligent system. Now let's start the discussion regarding the smart materials. There are different materials are available. For example, the smart piezoelectric materials, shape memory alloy, magnetostrictive material, electrostrictive materials, magnetorheological fluids, electrorheological fluids, etc. From this, and generally these materials are used in the infrastructures, and these materials are suitable to use in the infrastructures. But in this webinar, I am focusing on the piezoelectric material and the shape memory alloy simultaneously. Now let's see what is mean by piezoelectric material. Here piezo is the Greek word and it means the pressure, and the piezoelectricity related to the pressure electricity. This material behaves or it converts the mechanical responses to the electrical charges, and simultaneously it will provide the electric field to the particular material, so mechanical deformation may develop. So this phenomenon are called as a converse and direct piezoelectric phenomenon. Here we can see in this figure, it will provide the polarization, so material can be stretched or material can get extended. So this is a compression as well as tension. So let's see the application of the piezoelectric material, where to apply it helps the structure to convert the force into electricity, to convert the vibration into electricity, as well as convert the temperature into electricity, right? See, and this piezoelectric material can be used as a sensor as well as actuator because of its direct and converse piezoelectric phenomenon. There is well-known piezoelectric material, that is a quartz, but generally for the structural engineering application, the material used are the lithium niobate, zinc oxide, aluminum nitrate, lead zirconate titanate, and polyvilliidine fluoride, that is a PVDF and PZT. Generally, for the structural engineering purposes or for the infrastructure, this PZT and PVDF gives the good agreement of results. So, as I explained that the phenomenon of the piezoelectric material, that is the converse piezoelectric phenomenon and the direct piezoelectric phenomenon, and that push this material to behave as a sensor as well as actuator respectively. Now here I would like to highlight the use of a piezoelectric material with the help of a case study from the Israel. See, in Israel, they implemented or applied the piezoelectric layers or the rod in the highway, and they made a smart highway using the piezoelectric material. See, here in the figure with the blue color, we can see the piezoelectric generators inbuilt exactly below the top layer of the. How to convert these mechanical stresses to the electricity? We'll see. Here, the if vehicle passes from the road, the road get deflects in a vertical direction, as well as it get vibrated along with the impact. So these vibrations can be converted to the electricity, and that can be stored, and which is afterwards it may be used. See, in that smart highway, they used or they planted the piezoelectric generator below the 6 centimeter under the road, and in a distance of 30 centimeter apart. See, this generator harvests the mechanical energy from the vehicle and it is stored. So it is converted in the electricity. From 1 kilometer of a piezoelectric road of one lane, they produced 44,000 kilowatt hour per year, this much of energy. So this is the very good alternative to generate the energy from the smart infrastructure. See, there is limitations because this piezoelectric material awareness is very less and its expertise is very less. Same time, the standard specifications are not yet developed. So these are the limitations, but in coming years or in a near future, it is possible to have that standard specifications. Now let's see second application of the piezoelectric material. That here we can see the example of a cantilever beam. The sensor, piezoelectric sensor is attached at the top, and the piezoelectric actuator is attached at the bottom of the beam. And for this beam, the vibration can be sensed and it can be controlled with the help of a controlled unit. See, the displacement versus time. In this graph, if we'll see a blue color line graph, it is the sensed vibration from the cantilever beam, and with the help of a gain function. What is the gain function? See, we measured the mechanical stresses in terms of a electric potential, and that potential can be fed back to the actuator layer to control the particular response. And here the gain value is used to increase or maybe for decrease the electric potential, and which is based on the demand of that particular structures. And here we can see in this graph, the displacement can be controlled, and it can be shown in a brown color line. Now let's move towards the second material, that is a shape memory alloy. Here I would like to highlight or discuss the iron based shape memory alloy. The shape memory alloy itself, it defines the material that it remembers their original shape, and if it deformed, they recover their original shape immediately upon heating or immediately upon unloading. See, there are different types of the shape memory alloys are available. That is a copper based shape memory alloy, nickel based shape memory alloy, and the iron based shape memory alloy. See, copper based shape memory alloy and the nickel based shape memory alloy having the uh, cost is on higher side. So this iron based shape memory alloy is having low cost material, and which gives the better results as compared to the conventional reinforcement or the conventional material. These shape memory alloys can be available in the reinforcement bars, plates, wires, and the springs. See, in a shape memory, and these phases are responsible to behave that material maybe as a shape memory alloy material or maybe a super elastic material. See, here we can see in this figure, this phase is called as a austenite phase, and this phase is called as a martensite phase. Here I will not go in a detail because this is a purely metallurgic part. So only I would like to highlight that this austenite phase related to the high temperature phase, and the martensite phase related to a low temperature phase, and its structures, it can be seen in the figure. Now here I would like to discuss or highlight the shape memory effect. Take an example, or see the figure, this figure A. One plate is there with a hot water and the spring is placed here. Suppose we'll stretch the spring, so this spring get deformed. After deformation, we'll put that spring in the plate with hot water. It regains its original shape. So it is the ability of SMA material to recover its original shape after being deformed through a thermal cycling. So this is the phenomenon of a shape memory effect. Now let's see what is a superelastic effect. This, it is described as the recovery of a large strains as a result of a stresses induced martensite phase. Take an example of this reading glasses. Suppose that material is in martensitic phase, and we'll apply or we'll stress that material, and after unloading that material it may regain its original shape, and this is the effect of a superelastic. Now, why the shape memory alloy over a conventional bar? Because here we are focusing to use the smart materials in the structure to make that structure as a smart. See, in this figure, suppose from the hairline cracks, the moisture get enters and it started the corrosion in the particular steel. So based on the research, it is predicted that after the corrosion, with a 6 times. What are the different uh, how the corrosion starts. The quality of concrete, it depends on the quality of concrete, cover thickness, condition of reinforcement, and effect of environmental changes. Means here suppose take a एग्जाम्पल, अगर हमने एग्जाम्पल लिया, पोरोसिटी अवेलेबल है स्ट्रक्चर में, बिकॉज कौन सा भी कंक्रीट विदाउट पोरोसिटी और विदाउट पोर्स अवेलेबल नहीं है. सो फ्रॉम दैट पोर्स वाटर एंटर होगा स्ट्रक्चर्स में. दैट वाटर, वो वाटर रेनफोर्समेंट की तरफ लीड करेगा, एंड आफ्टर दैट क्या होगा, कोरोजन, मतलब रस्टिंग होगा वो स्ट्रक्चर, एंड द वॉल्यूम will get increase, मतलब वो बार का वॉल्यूम इंक्रीज होगा. एंड these are the different points which are able to start the corrosion. Now shape memory alloy का इंपॉर्टेंस क्या है? what is the advantage of the shape memory alloy? ये हाई स्ट्रेंथ मटेरियल है, इट इज हैविंग ए गुड इलास्टिसिटी, फटीग रेजिस्टेंस भी अच्छा है. then corrosion, it is a good corrosion resistive material. It is easy to fabricate, it is lightweight, and it is having the shape memory effect. Means the material is having to regain its original shape on unloading, or maybe with the provision of a thermal cycles. Now see, what is the application of a shape memory alloy? I can say alloy. कहाँ पे applicable होता है? See, in the bridges as a damper, in the structure as a anchorages, as well as in a bridges as a confinement. Same time we may use as a bracing also. Structures में जो bracings use करते हैं, in that also we may use the shape memory alloy. Same time उसको reinforcement bar भी हम structure में use करते हैं for regaining the deformations and as well as regaining the stresses from the structure, or sorry, from the reinforcement bars. Now let's see here. I discuss the piezoelectric material and the shape memory alloy material. Now let's see the application of this shape memory alloy in the structure. ये स्ट्रक्चर में कैसे अप्लाई करेंगे, कैसे यूज करेंगे स्ट्रक्चर में, उसके रिजल्ट्स क्या रहेंगे? विद द कंपैरिजन ऑफ ए कन्वेंशनल रेनफोर्समेंट बार. अगर हमें कन्वेंशनल रेनफोर्समेंट बार भी स्ट्रक्चर में यूज किया और सेम टाइम हमने शेप मेमोरी अलॉय बार भी यूज किया, दैट इज अ रेनफोर्समेंट बार, सो उसका स्ट्रेंथ पे कितना इफेक्ट होगा? If it is a corrosion resistive है, it is having a capacity of a crack closing, that we'll see. And here this project is funded by the Mumbai University, and I'm working on this project from last 2 years. Here I have developed the shape memory alloy material, and see, simple example, a simple beam having a length 700 mm and a depth 150 mm. Here in this beam we used 2 reinforcement bars at the bottom and 2 at the top, and here we carried out the flexural strength. उसका flexural resistance देखा कि कितना परसेंट ये more capacity, if it is possible after using the shape memory alloy material, that structure is able to sustain a more load or not. See, this is the design input data for the experimental study. In this project हमने experimental study भी किया, सेम टाइम वो एनालिटिकल स्टडी भी किया. एक्सपेरिमेंटल सेटअप जो है वो मॉडल किया हमने ANSYS वर्जन 16 में. We used the FESMA reinforcement, and then we studied its flexural strength. Now, same model same experimental setup we modeled in a ANSYS 16, and this is the model we developed in a ANSYS 16 for comparison of the results. This is the input data for the analytical study in the ANSYS version 16. For modeling of a concrete, we used solid 65 element because that element is compatible with that particular material. Conventional reinforcement, we use the link 8 element, and for FESMA reinforcement, we use the link 1 element. And these are the material properties we used for the modeling of a beam in ANSYS. These material properties we took from the references, same time it is from the manufacturer also. Let's see. Before leading or before starting any experimental program or any analytical program, it is necessary to test the structural materials. See, for this purpose, we tested the reinforcement bar for the tensile test, and for the comparison purpose, we tested the mild steel as well as Tor steel. See, in this graph, we can say the stress versus strain graph, and very nice results we received. That ultimate tensile strength of the reinforcement bar, FESMA reinforcement bar, we received was 2. Also, we carried out the bend test of the reinforcement bar, and it is a satisfactory for the all materials, that is mild steel, tall steel, as well as the FESMA reinforcement bar. Now, main point, corrosion. Because in a smart structure, we are focusing on the corrosion also. That is a very important phenomenon. अगर ये फिगर में देखेंगे, फिगर नंबर A, that is for the mild steel, and here the method we used as the salt spray, and 3% concentration we used, and the period of this test was the 24 hours. Figure number A shows this mild steel corroded, fully corroded. This tor steel also fully corroded. It is showing the huge pitting, red pitting on the structure or the surface. But if we'll come to the point of a FESMA reinforcement bar, the slight red pitting observed on the cutting edge, but that can be improved while improvement in the manufacturing processes also. So here the FESMA reinforcement bar shows the more corrosion resistance as compared to the mild steel and the Tor steel accordingly. Now let's see. Here, as I said, or as I discussed, that we carried out the testing on the RC beam for the flexural. See, flexural strength we received for the BM2, that is the RC beam with a SMA reinforcement. It is a 43% greater than the RC beam with a conventional reinforcement. So we can say, if we'll use the smart material, for example, shape memory alloy in the reinforced concrete structure, so it enhances the corrosion resistivity, plus it increases the strength of that particular structures. Now, main phenomenon of the shape memory alloy, or what is the effect of shape memory alloy? See, in this two figure, this is first and this is second figure. This is figure for the beam cracks observed just after the testing, and this second figure shows that the recentering ability of the FESM reinforcement after 2 hours of the testing. And here we can predict it, or the result shows that the 75% of the crack vanished after 2 hours of the testing. So this is the benefit of using the shape memory alloy in the structure. So there are the strain recovered, 75% of the strain recovered in that structures, and the same results we compared in the ANSYS also. Now let's come to the point of a fatigue life of the reinforcement. Here we carried out the fatigue analysis also, because the structure is having the fatigue loads, that is a continuously small amount of the load cycles are getting applied again and again. So what is the resistance to the fatigue? Again, in a FESM reinforced structure, we received the highest fatigue life, that is 86% greater than the conventional reinforcement as per the analytical studies. Now let's move towards the project number 2. This project is based on the nickel based shape memory alloy, which is used in a concrete. Now here I want to check it is possible to regain or recover the cracks developed in the concrete. For this particular project, we received the assistance from the R&D lab SCC Cement Thane. For this project, purposefully we used recycled fine aggregate concrete, because that is the weakest concrete ever, and we are trying to enhance the strength of the recycled fine aggregate with the help of a shape memory alloy fibers along with the electromagnetic water. Here we used two smart materials. One is the electromagnetic water and another is the shape memory alloy. As I discussed previously, here I used a nickel based shape memory alloy, because same project carry forwarded to the elevated temperature. Same material we subjected to the elevated temperature, and for the elevated temperature purpose, the nickel based shape memory alloy gives the good agreement of results. In this same project, we used the electromagnetic water to increase the workability and the compressive strength of that particular concrete. See, here the setup of the electromagnetic water is given. What is the electromagnetic water? The water passes from the electromagnetic field for the purpose for reducing the calcium ions and the other minerals, and it is focus is that to reduce the different we can say the concentration of the particular ions, and the water can be circulated through this device for the 24 hours, and after that water, that is called as a electromagnetized water. It helps the concrete to increase the workability and the strength. Let's see. If we'll use the shape memory alloy fibers in the concrete, definitely the workability will get reduced. But with the help of electromagnetic water, we are able to maintain the workability of the concrete. Here the result shown in this brown color line, that is for the electromagnetic water, and take an example that 1% SMA fibers in the reference mix. The workability with normal water is a 160 mm. In a slump, that is a slump value, but it may get increased up to 175 mm. So this is the difference by using of electromagnetic water. This is just for to increase the workability and relative compressive strength. Now see, here the results are presented for the compressive strength for the 7 days and the 28 days. As I said, here we use a purposefully the recycled fine aggregate. So in that aggregate concrete, so in that it is possible to check, or it is possible to increase the strength with the help of a shape memory alloy fibers. And here we can see clearly, take an example from this graph, that is 1% SMA in the reference mix concrete. Without electromagnetic water, it gives the strength of a 43.4 MPa, and with electromagnetic water it gives the 51.75 MPa. Means अगर हम शेप मेमोरी अलॉय along with electromagnetic water अगर concrete में use करते हैं, what is the benefit? Shape memory alloy strength बढ़ाएगा, and because of the shape memory alloy the workability of concrete get reduced. मतलब shape memory alloy use करेंगे और any types of the fibers will use in a concrete, उससे क्या होता है, workability कम होता है, and with the help of electromagnetic water it is possible to increase the workability. These are the results for the electromagnetic water on the tensile strength as well as. Okay. So here again, take the example of a 1% SMA fibers, and here also we can see the drastically increasing the results without electromagnetic water and with electromagnetic water. These are the results for the flexural strength of the concrete. Now, main property of the shape memory alloy, that is the crack closing ability. Also, it is called as a recentering ability of that particular structures. See in this figure, take again example of a 1% of SMA with a reference concrete. After deformation, means after immediate after testing, uh, we observed the crack width is 0.43 mm, but after 2 hours it get reduced up to 0.28 mm, and after 4 hours it get reduced to a 0.17 mm. Now this shape memory alloy can be able to close the crack which is in between the 50 to 60%, and this is the main advantage to give the alarming failure of the particular structures. Now let's move towards the third project, that is effect of elevated temperature on the recycled aggregate concrete with a shape memory alloy. Now next focus is that to check whether the shape memory alloy fibers will get reacted to the elevated temperature, and what is the performance of these fibers while it's subjected to a elevated temperature of a 400 degrees centigrade and 800 degrees centigrade respectively. For the enhancement in the 800 degree centigrade temperature, because in that temperature your structure is fully porous. Now again come to the point of a crack closing ability in the concrete structures with the help of a SMA fibers under elevated temperature. So here also see clearly, take again example of a 1% SMA fibers along with a reference mix. Here also we measured the crack width in the cylinders after testing. We observed that immediate after testing the crack width is the 0.47 mm. After 2 hours of testing it get reduced up to 0.32 mm, and after 4 hours of its testing it get reduced up to a 0.15 mm. So this is a drastically change in the recentering capacity of the FESMA reinforced FESMA fibers. So here I would like to highlight that if we'll use the smart materials and the smart materials in the structures, it is possibility or it is possible to enhance the extra stiffness, extra strength, durability of performance, as well as the corrosion resistivity along with a recentering ability. See here I discussed the passive structural system, because the SMA related to the passive structural system, it is not required a feedback loop, because this material itself it get used as a sensor as well as an actuator. So I would like to express my sincere thanks to all of you for listening me, and I would like to express my sincere thanks to a Tata Tiscon team, technical team, for inviting me for this prestigious webinar series. Now let's take a questions. Yes, I would like to invite you all for asking the questions. Please send us the questions. So I will take the questions and I will try my best to answer you. So from this, one question that is a very good question. Why does the stress strain curve of a FeSMA material go back in an ultimate tensile? See, FeSMA is the material, or we can say the SMA material, which regains its strengths. Because here I have highlighted the material which acting on the phenomenon of the super elastic. Here I have not used the material which is based on the shape memory. I have used the property of the material which is based on the super elasticity. And in this material property, the strain can be regained and it can be shown in the particular stress strain graph. That particular strain can be regained. That's why it is coming back to the ultimate strength. Yes. Again, second question, it is a very good question, that what is the actuator? Can explain the concept. See, the smart structural system incorporates a sensor as well as an actuator. Sensor will sense the stimuli from the structure. Suppose take an example of a mechanical deformation. If we'll apply a mechanical deformation or the mechanical stresses to that particular structure, that can be sensed by the sensor, and with the help of a control unit, the appropriate feedback control is developed and that is provided to the actuator layer. Means exactly opposite manner response is provided to the actuator layer for controlling the structural phenomenon. So this is the concept of the actuator. Yes, this is also a very good question, that is which material make the SMA. And I can say this is a copyright material and it is under patent, but again I would like to highlight that the main material used in FESM is the iron, same time manganese, copper, chromium is also used in some amount, and that is as per the ASTM codes. And based on the annealing treatments, that material SMA material can be manufactured. And also I would like to highlight that the SMA shape memory alloy material can be manufactured with the temperature of -50 degrees to the 160 degrees centigrades. Depends on the demand of the structure, the manufacturing can be done, and you may use that particular material as a shape memory alloy. Suppose take an example of a Jammu Kashmir. There is a lot of freezing and thawing actions happens. So in that, if we want to use the smart materials in that area, so it is required to manufacture that should be between the -10 degrees to a 30 or 40 degrees centigrade. So it is depends on the demand. Yes, this is also a very good question. Is use of piezoelectric material is economical? I will take an example of a Israel highway, Israel smart highway. See, if we'll take a, or if we'll count the cost in terms of INR, that the piezoelectric sensors, it is called as a piezoelectric generators because it generates the mechanical energy. It generates the electrical energy and it is converted from mechanical to the mechanical stresses to the electric energy. Its installation cost, or we can say the in first few years, if we'll invest if we'll invest on the material for the application of the piezo in a particular sensor or in an actuator, but in a future your maintenance cost for that structure will be zero. So it is possible to recover that cost in a future. So in start or at a starting point it is not economical, but it is possible to recover the cost. Yes. Next question is the SMA reinforcement. Yes. In market also SMA reinforcement bars are available, but there is one problem for the grooves, or we can say the bonding between the concrete and the SMA reinforcement bars. Yes, the SMA reinforcement bars are available in a different diameters and it can be used in a structures also. Let's see the next question. Yes. What is the percentage of SMA fibers used in a concrete structures, right? The particular results as I shown. In that, we used the SMA percentage with respect to the cementitious material. For that, we used a 0.5 percent of the SMA fibers and 1% of the SMA fibers. Yes, this is also a very good question. That is, can I use the smart concrete? Yes, you can use the smart concrete in a construction because okay. Yes. Next question is that how to collect the shape memory alloy fibers or how to divide the fibers in some diameter. We used the 6 mm diameter and the 30 centimeters. So simply we cutted that wires, that is a nickel based shape memory alloy wires in the pieces with the help of a manual cutters. So you may use the aspect ratio because based on the various trials that aspect ratio is selected for the experimental program, because aspect ratio also defines the strength and the recentering ability of the particular concrete structures. Yes. Next question is, that is a very good question. What is the cost of a SMA material? Simply, it is higher at this point or at this scenario. The cost of the SMA is a very high because this material is under development. Because annealing treatment which is provided to this particular material is a costly, but in a infrastructure, if India or maybe in other countries, if they start using, definitely cost will get settled. But same time, cost is higher, I can understand. In future its maintenance cost is a zero, so if we'll count that maintenance cost, so we it is possible to recover that invested cost also. Yeah, sure. Generally the questions are based on the cost, so as I highlighted, at this point cost is high but its recovery is also possible. Yes, one more question, that is from the fatigue life of the smart materials. Through my presentation, I have highlighted that the fatigue life of the RCC beam with a SMA reinforcement. Yes, it is a higher because the material is having ability to regain its stresses and the strengths. So here I focused on the super elastic phenomenon. That's why the fatigue life is far better than the conventional reinforcement. Yes. And last question, that is also very good question, that pull-out test carried out on SMA bars. Yes, we carried out the pull-out test, but again, the bonding is not that much good as compared to the conventional reinforcement because the grooves are made on that surface that are not proper, and because of some technical or the manufacturing difficulties, we it is not possible to maintain the pull-out test. So I would like to express my again sincere thanks to all of you for listening me and sending your questions. The questions are very good, but because of the time, it is not possible to highlight each and every question. But still, please send us the question. I will try my best to give the feedback or the answer to your questions offline. Thank you so much.